I don't have much time. So if we want to verify that these two functions are inverses of each other, there's a simple rule that we need to follow. Now, you guys remember doing composition of functions, f of g of x and g of f of x. You plug one function into the other function. Well, when we want to verify that two functions are inverses of each other, we need to find the composition of the function and its inverse. So if we say f of f inverse of x equals x, and f inverse of f of x equals x, then we have verified that those two are inverses of each other. So let's go and take a look at this and see how we're going to work this. So what I need to do is I need to plug this function in for x, and then I'm going to have to plug this function in for x. So let's first do this one. This says f of f of f inverse. Therefore, I'm going to plug in this function in for f of x. So I write square root equals the square root. Instead of writing x, I'm going to write x squared plus 4. The reason being because that is f inverse of x. Then minus 4. And then for over here, f inverse of f of x equals, instead of writing x squared, I'm going to write the square root of x minus 4 squared plus 4. Does everybody see that? Here, this represents f inverse of x. This represents f of x. Do you guys see that? See the differences. One, I plug this into this equation, this function. This one, I plug this function into that one. Does everybody see that? It's really important for you guys to understand the distinction. Because now what we need to determine, all right, if they both compositions equal x, then I have proven that they're inverses of each other. So first thing I do is I can simplify this into the square root of x squared plus 4 minus 4. Well, that gives you what? 0, right? Square root of x squared, x. Over here, I look at this, and these cancel out. So I'm left with x minus 4 plus 4. So therefore, since I have been given an x and an x when I did both compositions, I have now verified that they're inverses of each other. Yes?
I thought when there was like addition and subtraction under the radical that you couldn't like simplify it.
You're right. Well, what I was saying is, I was saying this. That's what I was saying you couldn't do.
Okay.
But you can cancel those two out because this is the square root of everything, and that's the square in that. So that you can cancel those out like that. I was just saying you couldn't break it up like that. Anything else? That's how you verify. Thank you for talking in the back.